The following was presented at the 10th Dry Dock Conference. Registration is now open for the 11th Dry Dock Conference. Visit drydockconference.com for more information. The 2025 Dry Dock Conference will take place on the 4th and 5th of June, 2025 in Providence, Rhode Island, USA. This is the 11th International Dry Dock Conference and Advanced Training Forum, hosted by DM Consulting. Registration is now open for in-person and online attendance. Visit our website to register and register early for a discounted rate.
I want to now introduce our first speaker, Douglas Pearlson. He's the founder, president, and CEO of Pearlson Shiplift. They have numerous shiplift, synchrolift transfer projects. As I mentioned, Pearlson Shiplift is the sponsor of our conference, and Doug is going to talk about shiplifts and transfer systems. So please welcome Douglas Pearlson.
Thank you, Joe. Good morning, everyone. I'm not too far from my beginning. I was actually born in Newport News. My father was a naval architect fresh out of Michigan, and he was in the apprentice school. I don't know if I was one of his projects or not, but I was born while the United States was under construction, and I'm told that was my first outing, probably before I went to a park in a stroller. He took me down to see what a dry dock looked like. So something stuck, and I've had the privilege of enjoying a long career in not just dry docking, but actually helping people build effective shipyards and maximize the profit potential for shareholders and the future for their employees. So it's a great journey, and it's only because of the contribution of people like yourselves that make this entire process work. So, as Joe said, we basically build shiplifts and transfer systems around the world. We're looking after probably just about 200 installations in about 60 countries. If the technology works. All right, Joe, pointer. Battery's low. Let's see if we can get to the next slide.
Do you have a video?
I do have a video. It's going to be coming up next. Alex, you want to cue that? Well, it's not the next slide, but go ahead and advance one. Maybe we're pointing it in the wrong direction. All right, what I wanted to do is start my presentation at the end. Oh, you went right past. Thank you, sir. All right, well, let's go back one. What we're going to cover in sequence is basically the construction of probably the most complex and involved shiplift and transfer system in the world in Barcelona. And what I wanted to do is actually start my presentation with a 4-minute video that shows its construction, operation, and the ships actually being transferred in Barcelona. And then we'll come back and fill in how did this all happen, what are the key elements that we'd all want to focus on if it's affecting our yard, and so on. We'll briefly touch on the origin because there's some interesting history in getting from where we started to where we are. Then clearly there are criteria that are important to any new facility or facility that's expanding to determine, is a shiplift the right tool, what are the capacities that are required, and so on. And then the most transformational part of dry docking that has occurred is the development of transfer systems that allow us to leverage the asset that is invested in the dry dock itself and effectively move vessels ashore in as many berths as you have land area to accommodate. And then, of course, anybody can make an animation, but we want to go over actual installations, actual builds that are not just recently commissioned, but are under construction now, like the largest shiplift in North America that's being built right now up in Marinette, Wisconsin for Fincantieri. And then finally, I want to really loop back into the most academic part of the presentation, which is getting information to the dockmaster as effectively as possible so they can control and manage the docking evolution. Probably the most serious responsibility that anyone in the shipyard has. People may argue with you, but you all in this room know that the role of the dockmaster is at the top of the pyramid of having responsibility for complex operations that involve a lot of teams to make it happen successfully. So if we can get the video to come up online. Good. This facility took about 4 years to build, which one of the slides will tell you, and it basically was in a reclaimed site that used to house the paint shed at the Barcelona yard. This shipyard has an existing shiplift that was built and maintained, surveyed, and assessed by us, which you'll see in some of these pictures, but all of these images really show the entire process of reclaiming the land, putting in the foundations for the hoists, and then as soon as the shiplift itself was commissioned, putting it in operation even while they completed the construction of the rest of the yard. Now, part of the interesting foundation issues here is a lot of what you see is actually on piles above the water. So they did not put in a bulkhead and backfill the entire yard, only the back side of it to transition to the existing yard. So this was during the testing and initial docking process. From a dockmaster's perspective, what you'll notice in the next vessel that comes in is that they allowed the ship's crew to bring the vessel in and tie it off before the docking crew took over. That platform's actually moving at about 9 inches a minute vertically, and then once the vessels are transferred ashore, they can be basically placed in a repair berth first. Now, watch this, because I've never seen this before, and I was actually at the site that day. When the captain basically says, "I'm come back far enough," sort of the cardinal sin of energizing your props to stop before you come into slip. So I don't know, that would give me heart failure if I was the dockmaster. Now, what's unusual about this installation is not only does it lift the vessels vertically and launch them, but you can transfer over the top of the hoists. So direct side transfer gives them a lot of space flexibility in where they're going to place vessels and get them back into the water. The transfer system, which we'll talk about in more detail on the upcoming slides, is an electromechanical jacking system. Each one is 160 metric tons. And the strongbacks, pretty conventional. You're used to seeing those in all kinds of different transfer systems. They're brought into the yard on these jacks by what is really just an oversized aircraft mover. So again, this yard was very space constrained, and so we were basically instructed to use every square meter to place mega yachts on, as that's their core business. And you might see as many as 9 vessels up in the yard, leveraging the investment that they were made off of the one shiplift with its associated, bogie-supported transfer system. On a wheeled transfer system, it usually takes 1.5% of the load being transferred to move it. That's what the drawbar pull would be expected. All right. So that's where we're going. So at the end of this presentation, we'll see some of the elements that were required to actually get to that point in time where you can effectively leverage the capital investment of one dry dock with really as many shore berths as possible. Not photographed today is a lift that we built in Dubai that had 40 repair berths. We were basically told that the ruler wanted to take care of all of the dhows and all of the more modern craft in one facility, so we put in a shiplift and a onshore transfer system that had 40 berths. They then came and said, well, we have bigger boats now. So then we put in a second shiplift parallel to the first, much larger, but tied the 2 transfer systems in together. You just had to remember not to try to launch the vessels docked on the big shiplift on the little shiplift. All right, so my father, who actually invented the modern shiplift, really started out as a young naval architect trying to find a way to feed the family in Miami, and approached a shipyard in Miami and basically said, would you like to build some boats? I can be a naval architect for you. 20-something, 3 kids. The owner said to him, I don't build ships, I repair ships. I don't really need you, but if you want to project manage this new shiplift that we're building, I've got most of the designs done, not all of them. Can you take command of the design and actually complete the project and build this lift? 20-something, 3 kids, no job. Certainly, sir, I can do anything. So he took the job in Miami, and he built this lift, which is at the Merrill Stevens Yard on the Miami River. This lift was actually dedicated about 1953, and it was built on the principle of a rigid platform with 13 cables of different lengths being basically supported and pulled up by 2 drums and a worm gear gearbox and a prime mover under the ground. Had 1 transfer berth ashore. While building this lift, he realized some of the strengths and weaknesses of building this type of a shiplift. Specifically, having a rigid platform meant that he had to have turnbuckles, balancing the tension in the various lines. When you had new ropes that were changed, you had to cycle it quite a few times to get them balanced. There were just a lot of challenges because the platform was rigid. So he filed that away, went back to the shipyard, who I now hired him as chief engineer and gave him the opportunity to build those ships he was dreaming about. So he did that for a few years. A little bit later on, Richard Bertram of Bertram Yacht, basically approached the owner of this yard, who was a good friend, and said, can I borrow Raymond to build me a similar shiplift up the river? And Alex Balfe, head of Merrill Stevens, said, certainly. And my dad went to Dick Bertram and said, I've got this idea for a new type of shiplift. Would you mind if I built your new shiplift using my idea? And the Synchrolift was born. He actually built it, patented it, gave the patents to the Merrill Stevens because he was still an employee, assigned the patents technically. And basically that was Synchrolift #1, because that was what he christened the name of this new dry dock system, this new type of shiplift. So, just for reference, it took till 63, even though it was really invented back in 58, 57, for the patents to be awarded. And there's some subsequent patents we'll just talk about in a minute that actually add flotation to the shiplift platform for the purpose of offsetting the weight of the platform itself. So you can picture when you have a very wide ship lift, you're just spending a whole lot of energy lifting the platform steel, the girders that go between the hoists. Well, if you can put flotation on the platform, not more than the weight of the platform itself, you basically can offset that dead weight and use the hoist only to lift the ship. So now you can grow the width of these platforms significantly without the burden of having to lift 20-25% of the capacity of the hoists, which would be effectively the weight of the platform. So again, this is the first lift at Bertram's Yard up the river. And it has since been removed, and they have condominiums or something going into that site, as we see so many of the maritime sites being gentrified and turned into housing opportunities, which has been a real problem in Miami, as it has been in other port cities. So that brings us up to today, or Pearlson Shiplift. This slide, which you can download, really covers part of the journey of how I got from president of Pearlson Engineering, president of Synchrolift, to the founder of Pearlson Shiplift. In the middle, we basically started building a couple of facilities for nuclear submarines in the UK. To do that, we got acquired by a UK company called Northern Engineering Industries. And they asked me to join their board and maintain my position as president of Pearlson Engineering. So during that part of the journey, we continued to build shiplift systems under the brand of NEI Synchrolift. And then about 10 years later, NEI was gobbled up by Rolls-Royce as part of their acquisition of energy assets, facilities, because they had a number of companies in their group that were of interest to Rolls-Royce. The shiplift system wasn't, basically I went out and started consulting in building shipyards under the brand Pearlson and Pearlson, and we're still doing that today as an associated firm that actually goes in way before a dry dock is chosen and assesses what needs to be used as a dry dock, how should the yard be developed, what are the sizes and capacities of the vessels, and so on. So I started getting calls from our customers that asked if we could come in and basically service, maintain, or expand their existing facilities. So out of that opportunity became the catalyst for forming Pearlson Shiplift Corporation, and we built the first lift, which you'll see on our website, in Germany, when actually we extended a lift that I built in the 70s by adding a pair of hoists, and then a couple of years later adding another pair of hoists, because they started building yachts that were too big for their lift. That's a section of faith. You basically start launching a boat that you can't launch. So we were given a relatively short fuse, and during that time period, we manufactured new hoists, installed them, commissioned them, and so on. So the Synchrolift, the shiplift, is a tool that basically is a solution to how do I get that ship safely out of the water. Nobody wants to buy a dry dock. They don't want to buy a shiplift. They want to effectively move a vessel from the water to the shipyard, either repair it, or if they're building one, launch it safely. That's the mission. So we try to go through what are some of the criteria that are required that we need to assess before we determine what exactly do they need. Do they need a floating dock because they have no upland area? Is a slipway because of the topography of the site the best solution? Rarely does somebody come to me and say, I want to build a graving dock. But at the end of the day, there are a lot of existing gravy docks that are refurbished, that are in operation, and certainly for the very large vessels, it's the shall we say, the facility of choice when you get beyond the point where it's effective to put it in an alternate dry docking system. All right. So this list I won't spend a lot of time on because it's common sense. What do you need to assess? The most important thing is really the width, whether it's between the wing walls, between the walls of a graving dock. What is the maximum beam that you can handle? The shiplift, which is an articulated structure, is modular. So you can add sections as you need to lengthen it. If you want to increase its capacity, you can put hoists in between other hoists. If you want to actually do a combination of the two and make it wider, you can actually put an auxiliary pier in, get that built, and then move one set of hoists over and put in a wider platform in the middle. It's much more complicated, but a number of you in this room, I think, may have experienced that. So again, it's a very flexible asset that lets you expand it as your requirements come in. All right, so what has really transformed this entire process of dry docking with shiplift systems as opposed to conventional dry docks is this upland opportunity. You know, what waterfront is available, what upland is available. And then at the end of the day, how am I going to get onto the shiplift platform? If possible, you always want to come in the end of the platform. It gives you lots of flexibility, significantly lower in costs for what you're building. But Barcelona didn't have the space, so you then pay that penalty in cost and in complexity, and you transfer the vessel right over the top of the hoist. You can remove the side of a floating dock, Ingalls. You can basically remove the side of a railway, like in BAE Jacksonville, but nothing is as simple and as straightforward as leaving the asset exactly in the same condition and just transferring the vessels over the top of the hoist. In some site, when we're dealing with nuclear submarines, we recess the hoist all the way underground. So literally, the beams that hold the rails are over the top of the hoist as well as between the hoists. You don't even see the shiplift machinery. It's recessed under the ground. All right? So this is the core of what we do, what all of us do. We're basically focused on, number one, the safety of the vessel, prime directive. Number two, we got to build something that's cost effective, not just to build, but to operate and maintain through the years so that it becomes an asset that keeps returning on that original investment, way beyond the initial payback period, which you want to keep, in the 5-year period for the current investment clients out there. All right, leveraging the dry dock is all about the transfer system and making a selection of what type. And then finally, time is money, so you want to keep the time of the entire evolution to a minimum. So how fast do you want those hoists to lift the platform out of the water? Typically, you're going to basically bring a boat out in 40 minutes to an hour is the target once it's landed, fair on the blocks. All right? And then expandability, I touched on a minute ago. That's where you invest now what you can afford, but you want to make it expandable so when your business grows, you don't have to tear anything out that you've done, you just build on it. All right. So these are two classic facilities that were built in a time when land was available, and you just don't see that today. So you see very few of these two-level transfer systems. Nothing is more effective than a two-level transfer system because you never take the wheels off the cradles and you never take the wheels off the carriage. Less than a half a dozen people can move one of those vessels from the dry dock itself, which I'm told there's a laser pointer here, yes? Okay. The ship lift here, and after it's clear and ready for transfer, you hook it up to whatever conventional vehicle is available, bring it over the top of the carriage, transfer it sideways. Usually there's a winch there in that pit, and then park it back in its repair berth. They may handle 400 to 450 vessels a year at that installation in Las Palmas. This installation shows basically the existing installation that has a two-level transfer system in Barcelona. So the new facility is basically on the other side of the yard out of this picture. You'll see it in a minute. But here again is the ship lift, the transfer carriage, move it sideways and park it into its repair berths. Some details of the side transfer carriage where you can see you've got the rails on top of a wheeled carriage that moves perpendicular usually, but not always. Sometimes it rotates, sometimes it moves at an angle, depends what the land area is. All right, single level transfer systems. This is an installation in, let's see, that's Savannah, Georgia. And basically, they had an existing dry dock facility that was in a building. It was a Crandall Railway. This eye is better than the other eye. Now, this is a little unusual because you see in the strongback itself, it basically goes all the way down the line of the ship lift itself, and then the wheels are actually turned in the cradles. So again, there are many different types of transfer systems and solutions depending on what you want to accomplish. In this one, they had side transfer, but at the end of the day, they they did not want to go through the expense of hydraulics or lifting these bogies, so they put wheels on all of the cradles and move them sideways, and then they turn the wheels 90 degrees and move them across into their repair position. All right. Similar facility, and it's actually almost an identical ship lift. A minute ago, I talked about the first Merrill Stevens lift. It operated for 63 years, lifting yachts until the owners decided to make an investment, and they built this facility, which basically handles 13.75 tons per foot. And the vessels, it's 90 degrees from the original orientation of the first ship lift. But that's how that land area had to be developed on the river. It's an end transfer lift. It uses the same kind of transfer car as Savannah. And the bilge blocks can be slid laterally and longitudinally to place them wherever the vessel's docking plan would require. The tow bar obviously reaches up underneath the vessel and connects to the first cradle in line, so it can be pulled on or off the platform without having to put the vehicle on the platform itself. This one's in Gulfport, Mississippi. Basically, they had the requirement to build and launch mega yachts for many years at Trinity. They use SBMTs, probably the greatest contribution to the flexibility of moving ships and blocks and production in shipyards for the last 50 years. So the SBMTs can be configured in different combinations of axle line capacities, of width. They can be bolted together. I would assume most of you in this room are very familiar with the flexibility an SBMT brings to you. And because it has a trailing wheel hydraulic suspension, it's like a caterpillar going over a river-washed road. The deck stays level, but the feet basically climb up over the bumps. So you get a lot of flexibility using that tool. It also lets you build your cradles as strongbacks with wings on them that let you drive the SBMT underneath it, so you only need one set, which most people actually lease or rent if they're in new construction because they don't need them around the yard the whole time, or they supplement what they do own. Another view of the same thing. This gives a good picture of the actual strongback itself. You need enough clearance to be able to get the collapsed strongback underneath, and then you lift it up. After it's been lifted up clear, then you drive it off the platform onto the platform, and you can basically use bilge block supports with hydraulic arms. You can use sliding conventional blocks. You can use fixed blocks. This is a platform on which you do your block build. And you do your block build horizontally in the yard. You assess it, you survey it, you make sure that it meets the requirements of the docking plan, and those elements are not even on the docking plan, which is more the case than not. And then you can use those supports during the evolution. All right. Another picture of Barcelona with some more detail. You can see each of the individual screw jacks, electric motor basically lifting and lowering a series of jacks. And after they're basically brought in their preload mode, where they all come up and just kiss the bottom of that beam, so that if you do have some different elevations, it is all taken out as part of that process. And the strongbacks are all lifted vertically until the legs clear the deck, and then it's transferred ashore as you saw in the video. For big vessels, they put a ballast weight on the back wheels of the transfer vehicle. Again, the configuration of the strongbacks varies with the type of vessel's displacement and the number of lines of SPMTs that you need. There may be 2 for smaller vessels. I've actually seen a lift with 1 down the middle, very, very small vessels, as many as 5 strongbacks lines going down on the platform. So the strongback is more complex. This is the most sophisticated type of a transfer bogie, obviously the most expensive, where hydraulically you can transport it so you don't need a vehicle, you can rotate it, and you can elevate it and drop it down. Again, you can see the blocks on this particular strongback configured for this evolution, for this docking. part of the challenge that we're always given when we design a new yard is where are we going to put the empty cradles? And I try to explain the cradles are not going to be empty very often. They're going to have a vessel there making money. But if you do have that problem, you can stack them. So that everything is modular for the practical application of space, because today's shipyards are very constrained. What follows is basically a series of different types of installations. Remember, a minute ago I talked about end transfer. End transfer gives you the flexibility of elevating the hoists sufficient to pull the platform out of the water when it's not being used. So unlike a floating dock that you have to dock the sections or you have to bring it to a graving dock in order to do its maintenance, with a shiplift system, you elevate the hoist such that you can bring the platform above high water when it's not being used. That's a maintenance elevation. And you lower it down where most of the platform's in the water for transfer. So end transfer gives you the flexibility of doing that. Direct side transfer, you have to recess the hoist because you're going over the top of them, so maintenance becomes a bigger project. So this is the ideal configuration off the end. This installation is currently under construction, as it says, I believe we expect next year for it to be commissioned and launch that first FFG. Actually, there'll be a vessel launch before the FFG goes in the water, but it'll use the same platform and the same type of cradle systems and SPMTs. For those of you that have been to the Marinette site, you'll realize why when I go through the door, everybody frowns, because launching is no longer an exciting adventure. I try to explain to them, says our job is to make the dockmaster, shall we say, not quite bored, but a little less stressed. So therefore, we have a very long and quiet launching. They usually spend all their energy building a big red button so somebody can ceremoniously push the button and get it started, because there's nothing else to look at. So at the end of the day, people come to us with a problem of, we want to dry dock or launch ships. Well, what does the site look like? How do we use the land more effectively? In Marinette, they were originally going to transfer over the top of the hoists, but we had just enough angle before we invaded Michigan to bring the shiplift out into the river, and the corner of it is as close as we were allowed to get, but allowed us to bring it next to Building 10 right parallel to the river. And then the SPMTs, because of their flexibility, can actually drive off the platform, turn the corner, turn 90 degrees, and go back or be launched from that new Building 34 that they've been constructing. Okay. Again, the whole idea is flexibility and modular design. So when you're looking at that platform, you really don't know what the makeup of the platform is, or what the various technical characteristics, how does it affect the dockmaster. It's actually rigid platform sections connected by an articulated section. So it's actually welded sections between four hoists as a module. Four hoists welded in the center. All right, so it's one welded rigid structure. And then in order to, which we'll see in a minute on the technical side of this presentation, in order to not have any moment transfer between the actual keel blocks or the hoists, we articulate, or we actually pin it effectively. We pin it between those four hoist segments. So now, if you have a high block load in the center, if a boat comes in with a keel cooler that's nobody realized was actually torn loose and was going to land on one of the keel blocks and try to lift the entire ship on that damaged section, with an articulated platform, you'll see in a second that the controls tell you what's happening as soon as it touches. You'll be getting load where you shouldn't be. So the dockmaster now has data that they can control safely the process instead of waiting until they discover what the hell have we broken, because nobody surveyed and realized we actually had a damaged hull in that particular area. So again, I'll give you some more details of that in just a minute. All right, so this one we talked about earlier is Barcelona. The characteristics of this is fundamentally the same, except the hoists are recessed partially so that you can transfer over the top of them if you want to fill those two berths. Then in the background, you can now see, let's see, there we go. That's the original lift that they had operating from the other vantage point taken here, and this is the new lift. Their transfer systems are not connected. They're totally different. but it's such a cost-effective asset that, basically it became a question of how big should we make the new lift, how wide should we make it, and so on. Again, Savannah, we saw earlier in one of the slides, they had an existing Crandall Railway and a very long construction hall on the site. We converted that with a land level facility that was all over the existing foundations that were there, added new foundations, and put the ship lift out at the end where the railway was. Actually, it's off to the side of where the railway was. That first lift in Merrill Stevens, where the stern of these vessels are in the front. Let's see, went back over. Where the stern is here is where the axis of the original Pearlson ship lift was before we decommissioned it. So we started construction of the new site, and it became a point where we were upland we had to decommission the original lift and then continue the construction on shore while they finished the commissioning of the new lift. This is a noteworthy installation in Japan where the Fukushima disaster occurred, and basically the tsunami came in and destroyed this particular town in northern Japan. So we were approached to build a new ship lift to handle the vessels. This is one of the busiest fishing facilities in Japan. And what you see in front of you is the tsunami wall that's built. So the whole yard is behind a tsunami wall, and the hoists are elevated. So in the event of another disaster in the making, they can raise that wall, and they can basically hopefully save the rest of the facility upland from that. But again, this is a good picture showing a conventional vehicle that is available to basically transfer the vessel. What's unique here is it's an end transfer carriage that's recessed, and in the yard you actually have a side transfer cradle, the reverse of the typical lift. So the cradles all have the wheels oriented 90 degrees to the lift, and on the lift is the bottom element, the carriage. So it's double decked here. This is a GRP deck instead of wood or a bridge grading type of facility. So again, there are a lot of solutions depending on what's needed for a particular site. Vietnam, again, another application of an end transfer lift. Hoist covers are raised for probably the annual survey. Our team goes out and it actually does a site assessment, survey, inspection, and training annually to keep these lifts certified, and then obviously training and maintenance as required. Again, another picture of the Vietnam lift, and you can see the strongbacks, the blocks, and here they docked two vessels, one behind the other. You've all been challenged with double docking at different drafts or whatever you have to do if it's in a conventional dry dock, but this is pretty straightforward. It's basically you're bringing the floor of the graving dock up to the bottom of the vessel. So you know where the vessels are, you can lock them in position, and you can bring them up, and on the controls you can see when each of the vessels is suing and landing fair on the blocks during the evolution. And then of course you hook it up with that hydraulic cradle system we saw earlier in order to get it onto shore. We recently built this one in Qatar. Basically, their challenge was a little different. They had a very long, I don't know if it's miles long, but it's certainly an exceptionally long development upland of different docking, shipyard facilities, ship repair facilities, marine-related facilities, one ship lift. So we transfer the vessels over the top of this platform on the side on a series of shuttle bogies, and we then take the strongbacks and we wait for the SPMTs to drive in, pick up the vessel in the cradle and drive it into wherever they're going, half a mile away, and then come back and get the next cradle for the next operator. So it's really a shared use facility. Give you an idea of what the other end of that lift looks like. It has a grading deck instead of a wood deck because again, it's a question of what's the need, what's the cost, how are they going to be using the facility. There was not going to be any work on the platform, so they didn't need a real smooth work area or an effective work area, so they basically just have to stage and position the blocks on the cradles here. All right. New facility recently commissioned in in Taiwan. Again, end transfer off the platform. You'll notice there are no specific rails on that platform even after it's decked, because they have so many different types of cradles upland that they can use different pairs of rails or put rails there for a custom cradle that they're building, and using the platform literally as a platform for their transfer system. So this is a case where the shipyard says, we want to use our transfer system. You accommodate that by giving them a flexible support platform. And the biggest challenge there was getting the hoist inside the building and underneath the walls in whatever space that they were kind enough to give us to put in the ship lift. They already had plans for what their construction hall would look like. These are two notable installations. The first one was for ASC back in the day. It was actually Eglo Engineering in Australia, where they were a commercial yard, and then they started building the submarines on this facility here, and then they built the new larger facility that is parallel to it. Again, they had a wheeled hydraulic transfer system, which we've engineered a replacement for SPMTs, and this is a good example of spending some of your capital in the beginning. You see the space in between these last pair of hoists. They basically are now building, we are building for them, 4 more hoists, and we're going to be expanding that platform by taking these sections out, bringing them upland, cutting the longitudinals, putting in a main transverse girder, and then taking them back out and reinstalling them in position for a lift that has more capacity down a longer section of the platform. So the tons per foot capacity is determined by how close are the hoists together. In some installations, like in Halifax Harbor, it's not just how close are they together, but you actually put different capacity hoists in because their requirement was such that they knew the load distribution of their target vessels. And so we have hoists that run all together. Remember, these are electromechanical hoists. There's only a synchronous motor at the end of each one of these gearboxes driving a single layer of rope on a groove drum. So if the motor runs synchronously, the whole thing comes up like a bunch of clocks on the wall. Doesn't matter if the load is zero or full load, it's going to come up at the same speed, because these synchronous reluctance induction motors, basically, when you apply power to them, they accelerate to their full operating speed in a very short period of time, and then they run at that speed. They draw more current if they're more load. That gives you lots of opportunities to put safety devices and sensors in the system to make sure that you never exceed the full load and that you know what the load is, which we'll see in just a second. All right, I'm going to go quickly through some of these other lifts we've seen before in the Las Palmas. This is the facility in Barrow. Remember I said that the hoists are completely recessed below the ground. This is where they build the UK Tridents, and they're taken up to Faslane, where we have another ship lift where they are basically maintained operationally at the Faslane facility in Gairloch. All right, again, when you get really, really heavy loads, this is, I think, a gripper jack system on the front end of the tractor. You assess what drawbar pull you need, then what's the best way to accomplish that in that particular yard. Lots of different solutions in this area. All right, let me just go back and make a comment. This one here was the old Todd San Pedro ship lift. And when Todd was decommissioned and the equipment was sold, we were engaged, my engineers that worked for Pearlson Shiplift, wearing the hat of Pearlson Engineering and before, the same people who now work for me, work with me, basically engineered and designed all of these lifts. And so when we sent someone back to the yard, it was probably the guy that originally commissioned the lift. Because as long as people want to continue doing this, they have an opportunity with us to do that. So this particular client said, we want to take all 110 hoists and we want to recommission them in Malaysia, Johor, north of Singapore, but we want to make it wider. So we had to engineer the changes in the girders, basically look after that conversion, and then recommission the new lift. All right, so what are the first principles? What are the real engineering fundamentals that it's important to mention? Some of which I've talked about up to this point. This first lift that my dad built in 1953 was a rigid platform, 13 cables coming back to turnbuckles, going back to 2 drums at the head wall. So he learned a lot about how we can improve on that concept and make it more flexible. Now, we can build a rigid platform. There's no trick to that. It just doesn't give the dock masters the same level of information as to what's happening during the evolution, because there's moment transfer between the actual lifting points on a rigid platform. You can imagine a conference table where we put a big load in the center and say, let's lift it, everybody. Everybody lifts a piece of it. So if it's overloaded, you may go right through the middle of that table before people realize that, oh, maybe I'm at my limit. But if you articulate it like a leaf in a table between each pair of people on either side of it, they only lift their piece. So if you're overloading a block anywhere along that platform, there's no moment transfer. There's no stiffness built into it. So you know where the overload is. And as you'll see in the control system, at that point, you can say, should I have a load there? All right, and if I should have a load, no problem. So you actually see what's happening, effectively pinning the connection at every one of the hoists. Remember, it's a rigid section of 4 hoists, and you pin the 2. All right, now this little sequence here shows what happens if you have that keel cooler or a high block or a piece of timber that floats in. You're docking along, and there's 2 of these sequences. And the first one is what a conventional docking would look like. So as the vessels comes up, you can see where the blocks are. And in this next animation, it shows what happens if on one side of the platform, something floated in and got entrapped above a bilge block. So you push the up button, and all of a sudden, one hoist takes off on one side of the platform. So immediately, before you got anywhere near that level, you would stop. If you didn't do anything, it would stop automatically. But as soon as the dockmaster sees, why do I have an asymmetrical loading in one block? It's because there's locally something happening in my dry dock that I can see. You have eyes through the controls. Certification, safety, our fundamental focus is on building a facility that can be safely operated from the perspective first of the vessel, then obviously of the personnel, then the facility and the systems. But our focus, I'm a naval architect, is start out with the target, the vessel, and how do we basically design it and build it so that it can be safely maintained. Some of the facilities around the world we're looking after, you can build lots of different platforms, but if you go through the engineering as to what makes the most sense, as the slide says, of over 90% of the shiplift systems operating today are on articulated platforms for that reason. It's not that you can't do it a different way. In engineering, you can do a lot of things. You just need to know what you should do or you shouldn't do. Okay? Thank you for your time. I think I'm actually on time. So, questions? You got a portable mic to the back row?
I don't know if I necessarily need it.
Ah, well done.
We need it for the online. Okay. So like I said, my name is Mike Rolls from KP, teaching marine engineers, not in the naval architecture program, but also port engineering type situations where they have to assist naval architects. My question is, I was just leaving Marinette when we were bringing in when Foss was doing the demo work and all that for the sinker lift up there. You mentioned a lot of different types of systems for the land transfer, okay? Fundamental differences between them. Then you talked about the Fukushima seawall there. So it got me wondering, are there fundamental different types of designs of the in-water system that make it more or less resilient to the 100-year events? So let's say Fukushima happens again, God forbid. What is the resiliency of the in-water systems? And are there key differences between different types of systems?
Well, there certainly are key differences between the different philosophies of design as far as the shiplift platform is concerned itself. If we start at the top end of it, the hoists themselves are basically built for a marine environment. So they can take an immersion event, a complete immersion event, and then you've asked, what do you do with a piece of machinery that's been immersed? You basically have to wash it out, clean it out, inspect it, mechanically make sure nothing was physically damaged, and then you can put it back in service. So there's no exposure of once it's immersed, you can't use it. It's designed for that environment. You then have a wire rope system, wire rope system, because you need to smoothly lift and lower the floor of the dock continuously. Remember, you don't have to be a couple of millimeters or certainly a centimeter off where you've exceeded what your compliance was in your blocks to lose support. So if you're not lifting the floor of that virtual graving dock up, a shiplift platform is just a horizontal platform, you need to continuously lift it vertically. And if you do that, the best medium to use is either a screw jack, just a continuous screw, or a wire rope. We actually built a screw jack along the journey to go explore the better ways, other ways of doing it. And we had to decommission that because you couldn't keep the lubricant on the actual screw when it was 30 feet long. But back to the wire ropes, now you have a platform hanging on wire ropes. So it's a dampened structure, and in a hurricane environment, you just lower it all the way to the bottom. Now all you're exposed is the size of the wire ropes, so you don't really have any exposure there. In a seismic event, you go through an analysis that determines what type of acceleration can the platform basically withstand. That's a criteria. And then what is the dynamics of what movement might occur if the platform is in operation during the event. You remember self-dampening because it's a pendulum basically hanging in the water. So to answer it with probably more details than you wanted, yes, there are boxes you need to check in assessing that the design can accommodate a seismic or a wind event, which are the two main design criteria. Other platforms that are not as flexible or modular are going to deal with the physics of that event differently, depending on how they're pinned or not pinned to the shore, when the event occurs. So there are, you analyze what are the differences, and then you basically make a decision on that assessment of what's the best solution, engineering solution. Does that give you what you wanted?
Yes, sir.
Other questions? Microphone, please.
It's a supply chain question.
Yes, sir.
The sensors and the instrumentation that you're using, are those all US made?
Yes, basically, we're an American company, owned as a U.S. company, and we build our machine in the Midwest, mechanical machine. The only part of the machine that's not from the U.S. are the wire ropes, because the U.S. factory supply chain no longer make galvanized wire rope in this country. So we build them in the same plant that built all of these for many, many years, originally British Ropes and now Bryden. But as far as the load cells, they're a strain gauge clevis pin, and they basically are built in the U.S., and then they have an amplifier built into them, and we put them in the clevis of the wire rope system. So what you see, I thought I turned this on. That's my 9:40 call, which I'm not going to be on. My apologies. Basically, the control system is built in the U.S. The control center, the motor control center, is built in the U.S. And so, long answer to a short question, supply chain-wise. Other question? Thank you again for your time, and I look forward to working with all of you on your projects.
Morning.
Good morning.
I apologize my English. I'm Rear Admiral Cesar Benavides from CIMA, Peru. I'm short English, but we have a new synchrolift system in Callao. And my question is about what's your experience about to maintain the draft, the capacity of draft, because
Right.
the current move solids.
Silted.
Okay, below the platform,
Right.
okay? What's your experience about to maintain the capacity of draft?
Now, there's actually an exceptionally... Am I still on? Yeah, okay. Excellent question, which I didn't touch on at all. Silting is the Achilles heel of any kind of a system where you have to dredge a section underneath the platform that's deeper than the surrounding area, or if you have a lot of material in the flow of the river. So there's a number of suspension systems that basically are putting a turbine underwater, and it moves the material, the loose material, suspends it so that the current can take the material away. So there are a series of them, and they're in Savannah, Georgia, the Port of Savannah. There's a number of these siltation control systems that are available that basically can be installed on the piers, and when the lift is not operating, which is most of the time, they basically are underwater at the right time of the tide, suspending the material that's settling underneath the ship lift and basically blowing it out into the current that can then take it away naturally. Otherwise, you have to dredge it. There's a number of different ways of doing that, and it's a lot more expensive than putting... These systems are expensive, but in the long run, they're much less costly than the dredging costs that you would have underneath the platform. Any other questions? Okay, thanks again.
Well, thanks, Doug.
For more information on this topic and others like it, please see our technical papers. Visit drydocktraining.com/technical-papers or contact DM Consulting at drydocktraining.com/contact-us. Registration is now open for the 11th Dry Dock Conference. Visit drydockconference.com. Thank you for watching.